Hey everyone, my name is Michael G. Morente Jr. and I'm your next reporter for Unit 4.5 Probabilities and Normal Distribution. So, the normal distribution or Gaussian distribution is a continuous probability distribution that describes data that clusters around a mean. So, the normal distribution, also called the Gaussian distribution, is a way to show how data is spread out. In simple words, it shows that most values are close to the average mean and fewer values are found as you move farther away from it. So the graph of the associated probability density function is bell-shaped, with a peak at the mean and is known as the Gaussian function or bell curve. So when you draw it on a graph, it looks like a bell shape, high in the middle where most data is and low on both sides where fewer data are. So the normal curve is often called the Gaussian distribution. The term bell-shaped curve is often used in everyday activity. So this curve is called the bell curve or Gaussian curve, and it helps us understand patterns in things like test scores, heights, or measurement errors, where most our results are near the average and only a few are very high or very low. For example, if a research investigator selects a random sample of 100 adult males, measures their height, and constructs a histogram, the researcher gets the graph similar to the one presented in figure 4.12a. So, now if the investigator increases sample size and decreases the width of the classes, the histogram will look like the ones presented in figure 4.12b and c. Lastly, if it were possible to measure the heights of all adults in the Philippines, the histogram would come close to what is called a normal distribution, presented in figure 4.12d. In figure 4.13 shows the example of a normal distribution curve, which has 34.13% on each side, 13.59% on each side, and 2.88% on each side. So if it is cut in half, it is 50% and 50% and equal to 100%. So next is the properties of the normal distribution are as follows. So number 1, the distribution is bell-shaped. So the graph looks like a smooth bell, high in the middle and low on both sides. Number 2, the mean, median, and mode are equal and are located at the center. The average middle value and most common value are all the same and found right in the center of the bell. Number 3, the normal distribution is unimodal. There is only one peak or highest point, just one mean center of data. So number 4, the normal distribution curve is symmetric about the mean. The left side and the right side of the curve are mirror images. It looks the same on both sides of the middle. Number 5, the normal distribution is continuous. The line of the curve never breaks. It's smooth without gaps. Number 6, the normal curve is asymptotic. It never touches the x-axis. The ends of the curve get very close to the bottom line x-axis but never actually touch it. Number 7, the total area under the curve is 1 or 100%. If you add up everything under the curve, it represents all the data, 100% of the values. Number 8, the area within the standard deviations. Most of the data falls close to the average. About 68% of the data is within one standard deviation of the mean. About 95% is within 2 standard deviations. About 99.7% is within 3 standard deviations. So I've researched and found the 4-step process in finding the areas under the normal curve given a z value. Number 1 is express the given z value into 3-digit form. Next is number 2, using the z table, find the first 2 digits on the left column on the right. Number 3 is match the third digit with the appropriate column on the right. Number 4 is read the area or probability at the intersection of the row and column. Example number 1. Determine the area under the standard normal distribution curve between z equals 0 and z equals 1.885. So, we will use the 4-step process. Number 1 is express the given z value into a 3-digit form. The answer would be 1.85. Then number 2, using the z table, find the first 2 digits on the left column on the right. The answer would be 1.8. Then number 3 is match the third digit with the appropriate column on the right equals 0.085. So number 4, read the area or probability at the intersection of the row and column. So the answer would be 0.4678 or 46.78%. So the answer on the shaded area would be 0.4678. So probability 0 is less than z and less than 1.85 equals 0.4678 or 46.78%. So take note, if it's positive, it's on the right side of the graph. Example number 2. Determine the area under the standard normal distribution curve between z equals 0 and z equals negative 1.15. So the difference between example 1 and example 2 is example 2 is negative. So we will use the 4-step process. Number 1 is express the given z value into a 3-digit form. The answer would be negative 1.15. Then using the z table, find the first 2 digits in the left column on the right. The answer would be 1.1. Then number 3, match a third digit with the appropriate column on the right. The answer would be 0.05. Then read the area or probability at the intersection of the row and column. So the answer would be, or the shaded area would be 0.3749 or 37.49%. So the area between z equals 0 and z equals negative 1.15 or p negative 1.15 is less than z less than 0 is 0.3749. Therefore, the area is 0.3749 or 37.49%. So take note, if it's negative, it is there on the left side of the graph. Example number 3. Find the area under the standard normal distribution curve to the right of z equals 1.15. But before we could answer that, we must find first the area of 1.15. So we must use the 4-step process. Number 1 is express the given z value into a 3-digit form. Number 1 is equals 1.15. Then number 2, using the z table, find the first 2 digits on the left column on the right. So the answer will be 1.1. Then number 3 is match the third digit with the appropriate column on the right. So the answer would be 0.05. So read the area or probability at the intersection of the row and column. So the answer of the 1.15 would be 0.3749. So the required r is the right of the tail of the normal curve. So then subtract probability 0 is less than z less than 1.15. The answer would be 0.3749 from 0.5000. Since half of the area under the curve is to the right of z equals 0, so probability z is greater than 1.15 equals 0.5000 minus probability 0 is less than z less than 1.15. So equals 0.5000 minus 0.3749 equals 0.1251. So the right tail of the normal curve would be 0.1251 or 12.51%. Example number 4. Find the area under the standard normal distribution curve between z equals 1.15 and z equals negative 1.85. So we should find the shaded area of the negative 1.85 and the 1.15. So first, draw the figure and represent the area as shown in the figure. So probability negative 1.85 is less than z less than 0 equals 0.4678. So probability 0 is less than z less than 1.15 equals 0.3749. Since the two areas are on the opposite sides of z equals 0, we must find both areas and add them. So probability negative 1.85 is less than 1.15 equals p equals probability negative 1.85 less than z less than 0 plus probability 0 less than z less than 1.15 equals 0.4678 plus 0.3749 equals 0.8427. So in easy words, the answer is 0.4678 plus 0.3749 equals 0.8427. So the shaded area of the shaded area is 0.8427 or 84.27%. Example 5 is find the z value such that the area under the standard normal distribution curve is between 0 and z value is 0.3962. So we should find the z value of 0.3962. So find the area in table A as shown in the figure. Then correct z value in the left column is 1.2 and in the top row is 0.06 and add these two values to get 1.26. Hence, the Z value is 1.86. So the answer would be 1.26. B. Application of normal distribution. Now that we have discussed to use Table A, standardized normal distribution, in conjunction with the standard normal value formula, many different types of probability problems involving normal distribution can be resolved. To illustrate this, we will deal with some examples. Z equals x minus population mean and over population standard deviation. So, where z equals z value, x equals the value of any particular observation or measurement, u is the population mean, and o is the population standard deviation. Example 1. The average forgiving salary loan for RFS Pharmacy Inc. employees is 23,000 pesos. If the debt is normally distributed with a standard deviation of 2,500 pesos, find the probability that the employee owes less than 18,500 pesos. So, solution. Step 1. Draw a figure and represent the area. So, probability x is less than 18,500. So, step 2 is find the z value for 18,500. So, the formula is z equals the value of any particular observation or measurement minus population mean over population standard deviation. So, the value of any particular observation or measurement is 18,500, while the population mean is 23,000 over the population standard deviation is 2,500 equals negative 4,500 over 2,500 equals negative 1.80. So the z value would be negative 1.80. So step 3, find the appropriate area. The area obtained in the standard normal distribution curve is the table C appendix A is 0.4641, which corresponds to the area between z equals 0 and z equals negative 1.8. So negative 1.80 is less than z less than 0 equals 0.4641. So step 4 is subtract 0.4641 from 0.5000. So probability is the value of any particular observation or measurement less than 18,500 equals probability z is less than negative 1.80 equals 0.1500. Negative probability negative 1.80 less than z less than 0 equals 0.5000 minus 0.4641 equals 0.0359. So the shaded area would be 0.0359. Hence, the probability that the employee owes less than 18,500 pesos in pag-ibig salary loan is 0.0359 or 3.9%. Example 2. The average age of bank managers is 40 years old. Assume the variable is normally distributed. If the standard deviation is 5 years, find the probability that the age of a randomly selected bank manager will be in the range between 35 and 46 years old. Solution. Assume that ages of bank managers are normally distributed, then cutoff points are shown in the figure below. Step 1. Draw a figure and represent the area. Step 2. Find the two z values. Z equals x minus the population mean over the population standard deviation equals 35 minus 40 over 5 equals negative 5 over 5. Then the answer would be negative 1. So the second z value is 46 minus 40 over 5 equals 6 over 5. Then the answer would be 1.20. So step 3, find the appropriate area for z equals negative 1 and z equals 1.20. So probability negative 1 is less than z less than 0 equals 0.3413. So the second z value is probability 0 less than z less than 1.20 is equals to 0.3849. So add the probability negative 1 less than z less than 0 and probability 0 less than z less than 1.20. So 0.34.13 plus 0.3849 is equal to 0.7726z. So hence the probability that a randomly selected bank manager is between 35 and 46 years old is 0.7262 or 72.62%. Example 3. A company produces different types of energy drinks. The filling machines adjusted to pour 500 milliliters or ml of energy drinks into each plastic bottle. Nonetheless, the actual amount of the energy drink poured into each bottle is not exactly 500 ml. It varies from bottle to bottle. It has been observed that the amount of energy drink in a bottle is normally distributed with a mean of 500 ml and a standard deviation of 4.75 ml. What percentage of the energy drink bottles contains 505 to 513 milliliters? Solution. Note that the contents of the bottles of energy drinks are normally distributed. Step 1. Draw figure and represent the area in the normal curve. So, step 2. Find the two Z values. Z equals X minus the population mean over the population standard deviation. 505 minus 500 over 4.75 equals 5 over 4.75 equals 1.05. So, next is 513 minus 500 over 4.75 equals 13 over 4.75 equals 2.74. So, step 3. Determine the appropriate area for Z equals 1.05 and Z equals 2.74. So, the answer would be probability 0 is less than Z less than 1.05 equals 0.33531. So, another Z value is probability 0 is less than Z less than 2.74 equals 0.4969. Then, step 4, subtract probability 0 is less than Z less than 1.05 to probability 0 is less than Z less than 2.74. So, the answer would be 0.4969 minus 0.3531. The answer would be 0.1438. So, thus we can state that approximately 14.38% of all energy drink bottles are expected to contain 505 to 513 milliliters. Example 4. Consider an investment in stock market whose return is normally distributed with a mean of 20% and standard deviation of 8%. Determine the probability of earning money. Solution. Note that the investment earns money when the return is positive. Thus, we can represent the return in terms of probability x less than 0. So, step 1. Represent x and 0 in a standard probability statement. Probability x is greater than 0 equals P equals probability x minus population mean over population standard deviation greater than 0 minus 20 over 8 equals negative 2.50. So, step 2. Find the appropriate rear for Z value equals negative 2.50. So, probability negative 2.50 is less than Z less than 0 equals 0.4938. So, step 3. Add 0.4938 to 0.5000. So, 0.4938 plus 0.5000 is equal to 0.9938. Hence, the probability of earning money is 0.9938 or 99.38%. Example 5. To qualify for a master's degree program in business administration at San Sebastian College, candidates must score in the top 20% on a mental ability test. The test has a mean of 180 and a standard deviation of 25. Find the lowest possible score to qualify. Assume the test scores are normally distributed. So, the solution. Take note that the scores are normally distributed. The test value x that cuts off the upper 20% of the area under a normal distribution curve is desired. The area is shown in the figure below. So, work backward to solve this problem. Step 1. Determine the area under the normal distribution between 180 and x. So, 0.5000 minus 0.2000 minus 0.3000. So, step 2. Find the Z value that corresponds to an area of 0.3000 by looking up 0.3000 in the area portion in Z table. If the specific value cannot be found, use the closest value. In this case, the closest value would be 0.2995. So, the corresponding Z value is 0.84. So, step 3 is substitute the formula Z equals X minus population mean over standard or over population standard deviation and solve for x using the formula x equals OZ plus population mean equals 0.84 plus parentheses 25 plus 180 equals 21 plus 180 equals 201. So the answer would be a score of 201 should be used as a cutoff. Any applicant scoring 201 or higher qualifies for Master in Business Administration.